Goodbye traffic jams. Hello robots. What's coming next? In bustling cities around the globe, traffic congestion is a growing concern, resulting in endless hours wasted in traffic jams, rising fuel consumption, and increasing pollution levels. But what if the key to solving this problem wasn't just building more roads or enhancing traffic signals? What if the solution could come from robots? Specifically, autonomous vehicles? Before starting the video, be sure to hit the like button and subscribe to never miss out on our upcoming videos. We are entering a new era of transportation where self-driving cars, or robocars, are becoming a reality. Cities have already begun testing autonomous robotaxis, and the technology is advancing quickly. A team of researchers led by Assistant Professor Weizi Li at the University of Tennessee explored whether these autonomous vehicles could improve traffic flow alongside human-driven cars. Their findings suggest that by using artificial intelligence, AI, to coordinate, robot vehicles could help reduce traffic congestion and improve overall traffic efficiency. The vision: robot vehicles in mixed traffic. The idea of robot vehicles controlling traffic isn't entirely new, but it has traditionally been limited to highly controlled scenarios. Think smart highways or isolated lanes dedicated to autonomous cars. However, the reality of transitioning to a fully autonomous traffic system is still far from reach. Cities around the world are currently in a transitional phase where human-driven and robot-driven vehicles share the same roads. The question arises: can robot vehicles thrive in this mixed traffic environment, where they must interact with unpredictable human drivers? Weizi Li's research takes a step forward by introducing AI-driven algorithms designed to manage traffic in these mixed environments. The team's goal was to test if robot vehicles could communicate with each other and optimize traffic flow, even when sharing the road with human drivers. This collaboration between human-driven and autonomous vehicles could prove to be a game-changer in the quest to eliminate congestion. AI and reinforcement learning, optimizing traffic flow. The research team employed a form of AI known as reinforcement learning to test their hypothesis. In reinforcement learning, an intelligent agent learns to make decisions by interacting with its environment, receiving rewards for actions that move it toward a desired goal. In this case, the desired goals included improving traffic efficiency, safety, and energy consumption. Li and his colleagues simulated a real-world traffic environment, including complex intersections, with a mix of robot and human-driven vehicles. They programmed the robot vehicles to communicate with each other, allowing them to make collaborative decisions that would help optimize traffic flow. For instance, each vehicle would decide when to enter an intersection, not based solely on its own situation, but by considering the larger context of surrounding vehicles. Through these simulations, the team discovered some surprising results. When robot vehicles made up just 5% of the traffic jams were eliminated entirely. More impressively, when robot vehicles made up as much as 60% of traffic, the traffic flow was even more efficient than when controlled by traditional traffic lights. Why this research matters: traffic congestion is not just an inconvenience. It has far-reaching economic and environmental consequences. According to recent reports, the global cost of traffic congestion is estimated to be billions of dollars each year. From lost productivity to increased fuel consumption and air pollution, the effects of traffic jams are felt by everyone, whether they are behind the wheel or not. Traditional traffic control systems, like traffic lights and stop signs, have limited effectiveness in addressing these challenges. While they help maintain order at intersections, they often lead to delays, even when there is little or no traffic. What's more, these systems don't take into account the dynamic nature of traffic, how one vehicle's actions can ripple out and affect others in a complex system. AI-driven robot vehicles, on the other hand, offer the potential for a more responsive, adaptive system. By allowing the vehicles to communicate and collaborate, it's possible to optimize traffic flow in ways that were previously unimaginable. For example, autonomous vehicles could adjust their speeds, lane positions, or routes based on real-time conditions, helping to eliminate bottlenecks and reduce overall congestion. This shift could have profound effects on cities, improving not only traffic efficiency, but also safety and energy consumption. Less congestion means fewer emissions, cleaner air, and more efficient use of resources. The widespread adoption of autonomous vehicles could help mitigate some of the most pressing environmental and economic issues facing urban areas today. Overcoming challenges in mixed traffic. One of the major challenges facing autonomous vehicle integration is how to manage mixed traffic, where self-driving cars share the road with human drivers. Unlike fully autonomous traffic systems, where every vehicle is controlled by the same set of rules, mixed traffic requires robots to interact with human-driven vehicles that may not always follow predictable patterns. For this reason, many previous studies on autonomous traffic control have focused on simpler scenarios, such as highways or ring roads, where there are fewer variables. However, Li's research takes a bolder approach, testing autonomous vehicles in the much more complex environment of urban intersections, locations that are far more representative of real-world traffic. The ability of robot vehicles to communicate and collaborate in these complex environments represents a major step forward in AI-driven traffic control. Instead of relying on a central system to control every vehicle, the research suggests that we could rely on a distributed system where vehicles autonomously make decisions, adjusting in real time to the conditions around them. This approach could eventually lead to smoother, more efficient, citywide traffic management, reducing the need for traditional traffic lights and stop signs. The future of traffic. Real-world applications. As promising as the research is, there's still a long road ahead. The transition to fully autonomous traffic won't happen overnight, and it's likely that for the foreseeable future, human-driven and robot-driven vehicles will share the roads. However, this mixed phase may be exactly where autonomous vehicles can shine. One of the next steps for Li's team is to expand their algorithm to account for additional driving behaviors, such as frequent lane changing or more aggressive driving. They also plan to test their approach in real-world scenarios, using vehicle-to-vehicle communication to further refine the system. Moreover, future research will explore how these AI-driven vehicles could function in even more complex environments, such as areas with heavy pedestrian traffic or during adverse weather conditions. As the technology matures, it's possible that these autonomous vehicles could work in conjunction with other smart city technologies, such as smart traffic lights and sensors, to create a fully integrated transportation ecosystem. Beyond traffic, the broader impact of autonomous vehicles. While the primary focus of this research is on traffic optimization, the broader potential of autonomous vehicles extends far beyond the roads. In the coming decades, autonomous vehicles could fundamentally change the way we think about transportation. For example, by reducing traffic congestion and making transportation more efficient, autonomous vehicles could help alleviate some of the burden on urban infrastructure. Cities could redesign roads and urban spaces to prioritize pedestrians and cyclists, while autonomous vehicles handle the rest. This could lead to cleaner, safer, and more sustainable urban environments. Moreover, autonomous vehicles could contribute to reducing accidents caused by human error, which account for the majority of traffic incidents today. By eliminating the risk of distracted driving, fatigue, and poor decision-making, autonomous vehicles could make our roads safer for everyone. As autonomous vehicle technology continues to evolve, it's clear that these vehicles will play a central role in reshaping our cities. While we may not be saying goodbye to traffic jams just yet, the future looks promising, with robot vehicles leading the way toward a smarter, more efficient transportation system. The road ahead is full of possibilities, and as we look to the future, we can be hopeful that the combination of human ingenuity and AI-driven technology will help solve the traffic problems that have long plagued our cities. Thank you for watching. If you want more videos like this, make sure to like the video and hit subscribe button.